Good morning, everyone. My name is SHUANGQIAN. Today, I will present my dissertation. The title is Data Mining and Machine Learning beside User Retention Prediction and Operation Strategy Optimization for Shopping Southeast Asian Market. This presentation focuses on usage churn prediction and user retention strategies for shopping in Southeast Asian markets. This slide is Chapter 1. First, I will introduce the research background. In recent years, e-commerce in Southeast Asia has grown rapidly. More people shop online, and shopping has become one of the major platforms in this region. However, some users may graduate to stop using platform. This problem is called user churn. Shopping user churn may affect traffic, sellers, user activity, and long-term business growth. Therefore, it is important to identify high-risk users early before they completely leave the platform. The main research problem is that shopping needs a better data-based way to predict user churn. User churn usually happens slowly. Users may first log in less often, browsing few products, and make fewer purchases. If shopping finds this problem too late, it may be difficult to retain these users. This study has 5 objectives. First, to analyze shopping user behavior in Southeast Asian market. Second, to identify the main behavioral factors related to churn. Third, to build machine learning models for churn prediction. Fourth, to compare the performance of different models. Fifth, to propose user retention strategies based on findings. Now, I will continue with Chapter 2. In this chapter, I mainly review the study about user churn prediction, e-commerce retention, and machine learning. Previous studies show that user behavior can be useful for predicting churn. For example, login activity, browsing activity, purchase activity, and payment use can reflect whether users are still active, platform. Based on the literature, this study used behavior variable and region to predict churn state. The study gap is that fewer studies focus on shopping users in Southeast Asian market and connect prediction result with practical retention strategies. Therefore, this study tried to link data analysis with real operation decisions. Next is Chapter 3, Data and Method. This study uses Kaggle shopping user behavior dataset. After data cleaning and filtering, 39,499 recorders was used for analysis. The target variables is churn states, where churn users are coded as 1 and no churn users coded as 0. The analysis process included data cleaning, exploratory data analysis, model building, and model evaluation. The dataset was divided into 19% training data and 20% testing data. 3 models was used: logistic regression, decision tree, and KNN. The model performance was evaluated by accuracy, precision, recall F1 score, and confusion metric. Now, I will present Chapter 4, the finding and discussion. The first finding is a churn distribution. No churn users account for 53.03%, where churn users account for 46.97%. This means 2 groups are close in size. The dataset is relatively balanced, so the models can learn from both churn users and non-churn users. This is helpful later model training and testing. The second finding is region difference. The result shows that churn rate is not the same across region. Java database has the highest churn rate. No Java has second highest churn rate, and no Java database has the lowest churn rate. This finding means shopping should not use only one general retention strategy for all users. Different regions may need different retention action, especially regions with a higher churn risk. The third finding is about key behavior factors. Among the selected variables, login activity is the most important signal relative to churn. Users who log in less often may have high risk of leaving platform. Purchase activity and browsing activity are also related to churn, but their relationships are weaker than login activity. Therefore, shopping should monitor login behavior, close and early warning signal. This slide compares three machine learning models. Logistic regression has best overall performance. Its accuracy is 0.6827, which is the highest among the three models. It also has strong F1 score. Decision tree has weakened performance in this study, with an accuracy of 0.6173. KNN has an accuracy of 0.6634, which is lower than logistic regression. It has the highest recall score. This means KNN can find more possible churn users. Overall, logistic regression is better for general prediction, where KNN is useful when shopping wants to identify more high-risk users. This slide is Chapter 5, Recommendations. Besides on findings, this study gives several recommendations. First, shopping should monitor users with low login activity because login change is an important warning signal. Second, shopping can set reminders and targeted vouchers to inactive or high-risk users. Third, shopping can improve product recommendations based on user behavior. Fourth, shopping should design different strategies for different regions, especially high churn regions. Finally, shopping can use machine learning as an early warning system to find the possible churn user before they completely leave. In conclusion, this study used shopping user behavior data to predict user churn. The final dataset included 39,499 recorders. The results show that login activity is the strongest behavior signal relative to churn, and churn rate is different across regions. Among the three models, logistic regression performs best overall, while KNN is useful finding more possible churn users. Overall, this study shows that data mining and machine learning can help shopping understand user behavior, identify high-risk users early, and improve user retention decision. This is my presentation. Thank you for your listening.